recording. Okay, before we get started, I am going to give you a special announcement of our logistics. Today is this, so in person, we're currently meeting, and next week, online only, and which is the final meeting for learning purpose. And the second week of December, we'll have another Zoom meeting that is, we want to wrap up the semester and a little bit of the overview of your final exam. Someone who do not need to come, do not need to join, but you can join anyway. We want to say not only the final exam, but the wrap up the semester. That is the rest of this semester. So actually, we are nearing the end of this semester. Any question about the schedule? It's not really, right? All right. So then oops, this is not. Where's my, okay, here. Maybe a little bigger. I know last week we had an online, and I gave you introductory slides about networking. So today we'll look at, we'll focus in a little deeper level of the protocols only, okay, network protocol. That's what we're going to work on. There are many, the layers, many different ways they can describe about network protocols, and therefore they end up having the structure of a network. So we call that network layer. One of those many, today we will look at the international standard. But this international standard is the only thing that is accurate and correct. No, that is not. But this is a standard, right? This covers most of the cases. Some other networks, for example, we have lots of Internet of Things, and then also communications. Then the network layers are not necessarily following this 7-layer OSI models. All right. You may think that very clearly and quickly. For example, if you, these days, many big hotels provide you the smart key applications so that you can download it on your smartphones while you are staying in a hotel. You don't really check out any physical keys or any key card, but app, right? Smart apps on your smartphones. So if you turn on your smartphone app and place that on the door key, then hotel door may be open. So in that case, it doesn't necessarily go on those 7 layers, right? It is much simpler. Um, Mainly does not have physical. I mean, for example, um, many of these are uh, combined together. Um, Network here, some of the protocols, IP, ICMP, uh, and the port number may not need a port number. Port number may not be assigned to your smartphone, but different technologies may be used. For example, mosquitoes, there's some other things. And session layers, very simplified because your cell phone itself tells you clearly this is a session, right? Um, and presentation that comes up together with your sessions and application as well. So if it is the case, then maybe three layer or two layers, or some other militaries, maybe five layers. Some other cases even detailed, right? We do not know which technologies may be um, coming up and prevailing in the future. But currently, this is the seven layer. So we'll look at this. High level application here, low level physical, you may guess. On this physical layer, that is really physical lines, like coaxial cables, fiber cable, wireless. There's no cables, no physical connections, but there is some carrier signals, right? Some of the wave may be used in the current ways of a Wi-Fi or your smartphone microwave uh, uh, type of wave. That is the carrier of your data. So your data may sit on microwave. Actually, microwave is a term indicating the wave, but currently microwave itself may be some of the devices, right? So cooking tool. So may mislead, but anyway, this class you may hear when I say microwave, I don't mean any cooking tool or device. So that is microwave. So your data may be sitting on that microwave, and it uh, propagates. That is wireless, right? Um, so if we say wireless, then this seven layer is not really in this way, okay? Because we have here Ethernet on the data link layer. If we say data link layer or bridges, switches, PPT, PPP, they're all assumed we have physical layers like fiber cables or coaxial cables, where there is a repeaters, hubs. When it comes to wireless, then again, not necessarily seven layers. It's a small, right? So in the data link layer, then Ethernet layer uh, there, and we can see the frames. And here in this data link layer, we usually look at a special protocol called the ARP, address resolution protocols. Address resolution protocols for when you say some of the IP number comes through this physical layer. Of course, it is inside some of the frames where there is a packets, right? So we simply say there is a network packets. So network packets arrive at the data link layer. Then on this data link layer, we first find out if we receive a specific IP is not really your laptop, for example. Your laptop has a specific IP at that specific point in time at the specific location. So IP is assigned to your device, but when you relocate your laptop to another place, for example, you go back home, then different IP is assigned to your laptop, right? So IP varies. IP dynamically changed. So dynamically different IP is assigned to your laptop. It's not really assigned, but somewhere in the router, it understands when it comes to that IP, then it should send that packet to your specific device, your laptop. Your laptop has its own ID. We call that MAC ID, right? So from IP to MAC ID, there's some mapping. That mapping can be defined in this ARP. Okay, address resolution protocol. That can be done in this data link layer. So in the physical layer, we know where we can go through this IP. Applying this ARP, then we know which specific machine that we need to go into. We call that MAC ID, right? Your device MAC ID is permanent, is a unique, okay? AP dynamically. Sometimes you have some IP on your machine at another time, at another location, different IPs. So there is some resolution mechanism needed that is called the ARP. So on this ARP, through this ARP, IP will be converted to the MAC. Once it is converted to a MAC address, then we know, oh, this is a specific my laptop. Okay. So it comes into, it carried the IP and all this information also. So IP that comes with these packets. In this IP, network layer, we know which machine is assigned to what IP. This IP, this packet has not only IP address, not only the source IP address, but also destination IP address. All such informations carried in these packets. And that packet is opened. So at this network layer, this guy understands, oh, this is my IP. This MAC, this device, oh, currently my device has this IP assigned to, so that packet is mine. So that is confirmed on this network layer. And then it goes up to transport layer. At this transport layer, the protocol that we can see, TCP and UDP, at this level that we can check the port number. Okay. Here we check IP number. Here we check port number. Okay. If it is port 80 or 8080 or 443, those are all the ports that we can receive web pages, web documents. If there is a port number 22, then any secure shell login can be assigned to that port number. As I said, your laptop has 65 million ports, or no, 65,000 ports. 65,000 ports are available. So first 2,000 ports are usually predefined. And therefore, if you want to use a TCP, then we need to assign the higher number. When you install some of the packages on your laptop, if that package may be able to communicate with outside your laptop, then all the time there is a port number assigned to your packages, software packages. So that software packages looking for whether any messages coming through that port number. If any messages that come through that port number that I originally planned, then that application receives it. Okay? That is the mechanisms. If any message comes through the port number 80 or port number 8080, 8080, or port number 8088, then that is some web page, web documents comes in there. So your web browser is waiting to see if any packages coming through at that designated port number through. So in this transport layer, we check the port numbers. And the session numbers, if let's say we installed MySQL on my laptop, and then there's a port number, usually 3305, that is the default port number for MySQL. When some data coming from outside, then that MySQL is waiting for the data for that specific port numbers. But MySQL has not only me as a user, but in MySQL, there may be multiple other users available. Some data coming into me, then that is one session, or another data comes to another person in the same MySQL packages, then it is a different session. Okay, that can be done in this session layer. It coming through WinSock or sockets. All of these socket issues can be handled in this session layer. Let's say, hey, this is my data for the packages that I am using MySQL. Now there is this presentation. Okay, so if it is JPEG files or some of the, depending upon these data types, different presentation required, right? If it is web documents, then presentation is nothing but web browser, right? Web browser needs to be used. And then finally, specific application. All right. This is a mechanism that we can consider the data communications. Okay, I explained that broadly, but along this 7-layer. So the thing is this, when you receive data, then it comes first through this physical layer, right? So it comes through this physical layer, and it go up through this the layer. When it passes through one layer, then packet may be unpacked. So it has a multiple packed documents. That is a package. We can do that on Python codings, but none of our course I've never taught here at Mercy. But that is a real the lowest level of network programming. Okay, so given one piece of data, then we can pack, and another level we can pack another layer, pack another layer, pack another layer. So finally, it'll be a one frame. Then it can be shipped out. So at the receiver side, when that frame comes in, we completely forget you because you did. Okay. I was wondering who is coming in. So that package, when that package arrives at the destination, let's say it's at the destination, the package is received, right? It comes through the physical layers. The next layer after physical layer is data link layer. So one level unpacked. As one level unpacked, then it may know, for example, ARP or protocols, which means, hey, I know which device that we need to go into. Then go to network layer. At the network layer, unpack one more layer, one more level. Then we can see IP information, which means what is the destination, what is a source. So all kinds of IP information may be unpacked at this network layer. It goes up to transport layer. Then another layer may be unpacked where we can see the port number. Okay. So if we know port number and goes into a session at the session layer, then we can unpack further. All from here, it's not really purely network related, right? It's not really like this. Some other is more related with the application. So application may describe some of this session, presentation, applications. All below this, that's all the time same. So unpack ARP first, unpack IP, unpack port. Then we know which port it goes into. When the packet goes into a specific port, then after that, application program is waiting for that. So application program can be, maybe it skip everything, or it can do user ID first check and check any data formats. And therefore, according to that, we do display. For example, if it is a web browser and part of the data, if there is a JPEG data, then your web browser needs to render that JPEG formats. If that is a MP4 formats of data embedded in that web documents, when it arrives in my web browser, which is an application, then my application understands so that IPAC 4 player needs to be played. that type of things can be done here at this session layer, all of this, right? This is more like developers. Developer needs to consider all of this. All right. For example, if you develop iPhone apps in Swift, then all smart apps covers everything about this, right? Your smartphone apps doesn't need to worry about all here in the lower level. All right, so a few of those applications, the protocols will be discussed today. Understanding 7 layers, you need to download the Wireshark. So if you see Wireshark, I think you already downloaded it in the last week's lecture. I asked you to do that. So Wireshark, where is Wireshark? My Wireshark is here. It may not be recent version, but that's okay. It's not really a big difference. Yeah, this is something new. So skip this version. And then you need to choose the interface. EN0, that is my currently active interface. Okay. How do you know that? That you can see on your terminal. Doesn't matter your MacBook or Windows. Then if you have Windows, then you need to do IP config. If you have Mac, if you have Windows, then you need to do IF config. If you have a Mac or Linux, then IP config. Is it? Maybe different. Yeah. Yeah. IF config, then that is a Linux or Mac. IP config, then that is the Windows. Then lots of interfaces available. Then EN, this is the interface. This is currently active so that you can see the IP number 192.168.7.18. That comes through, for example, here, this is currently empty CIS lab Wi-Fi. We have a CIS Wi-Fi here. If you go to Mavericks, then okay, come back. So previously when I was using a one router, then 192.168.7.18, right now we're using Mavericks. So if I redo the same thing, IF config, then we will have different. Okay, this is a 10.71.181.238. Okay, different ones. So we can open this interface, and then I can do start. You can do that this at home, of course. start and capture the network packets. So I want to stop right now and going up, see what I would have. There's a protocol TCP, there's multiple columns and the rows, that is one frame, one package, right? So TCP, I want to see if there is any specific ones other than TCP. We cannot say ARP right now. So some of the TCPs, right? So uh, those are network packets. So we can open up anything that we can see. Let's say this is a source, 10.71.181.239, and then destination is 142, 250, 64, 106. If we click this, then we can see the frame. This is one frame. This is, I think, frame number. 2691. Size is 1466 bytes long. And the next layer here, Ethernet, so that as a source MAC, this is a MAC address, right? This is the destination MAC address. And then protocol and transmission. So this is Ethernet. What I want to show to you, what is our lecture notes? No, this is not my lecture note. Maybe behind, yeah. This is my lecture notes. A little bit up here, then Ethernet here, Ethernet 2, that is this Ethernet. And then there is an Internet Protocol version, that is IP. That's what we have here, IP. And then Transmission Control Protocol, there's a TCP. So TCP comes up here, right? So we would be able to see all of these. They are in one frame. We call that frame. Okay. So at this almost the low level here, if we unfold this, then there's a session number, interface ID EN0 that we could see here. There's EN0. That is interface type. That is arrival time November 24. There's current time. And the frame, something about the frame, right? So I can fold it. Wait a minute. How can I? Oh, go up a little further. Okay. There's a frame. If we unfold the Ethernet 2 layer, there's a destination source of this. At the Ethernet layer here, which is the data link layer. So ARP protocol is applied. Therefore, given IP may be able to map to a specific MAC address, which is it knows where it should go. So destination here, this is a MAC address 664. I think that is a MAC address, right? So destination is this destination address. So ALP is already applied here. So when it comes up to network layer, then we can see IP. So here source address is 10.71.181.239. That's displayed here. So your Wireshark upfront the presentation, then you can see some of this, right? But internally, it covers everything because it carries all up to the payload, okay? Real data. So source address and destination address there, and the header, checksum, and some of the different the data also. All these are all packed, so that we call that packets. In real codings, you can pack all of this at this layer, which is a the network layer. So at the network layer, you packed all that information. And at the receiving side, you need to unpack all of those at the network layer so that you may be able to see all of this. As you unpack the packets, you may be able to see all of this. At the receiving side, after this, after unpacking at the network layer, then it goes up to transport layer. So at the transport layer, then you may be able to see all the port number. Here, source port 49, that port number, and destination port is 443. Oh, this is a web page then. So this is something about the web documents. So coming through this, all of that. And then there is a payload. Reassemble TPU. If you see this is a real payload of that. These are all highlighted. That is in hexacode. So if you copy all of this from here, then that is some of the web documents. Something that you may see that web documents here. Although it is encrypted, not really anything that we cannot, there is nothing that we can guess, right? But sometimes you may be able to guess something. This is a payload. So if you click this, then that is highlighted. If you click, for example, port number, destination port number, then only this. That is hexacode 01BB. In hexacode 01BB is 443, right? 01BB. So you can convert that hexacode to decimal number, then that is 443. Those who do not understand what I'm saying, for example, binary code, hexacode, or decimal number, then you may be able to capture independently, okay, separately. That is the basic of the computer science. You may be able to learn it maybe in freshman, sophomore, basic IT. But anyway, so that is all that you can see from your Wireshark, as I said here. So download, install, and run so that you may feel something about the packets, right? So packet is this. When you send the data that you know, there is a payload, right? So around the payload, first level, then you need to pack it. For example, port number, source port number needs to pack at uh, the transport layer. And when it goes down to network layer, then source IP and destination IP, that is packed. So as you go down from the top level, top of your application layer to the physical layer, as it goes through to send out, then along each levels, more information can be packed into the payload. So everything packed, then it is ready to be shipped out. That we call the frame. So that frame may be shipped out. When you receive it, there's a reverse order. So when that frame comes in, then you need to unpack first. For example, in the data link layer, you unpack it. There, only IP address. So apply ARP protocols. So that is that the MAC address information only available on the router, right? My local router knows it. How local router knows it? When you first access the Wi-Fi router, then Wi-Fi router gives you IP, right? As it gives you IP, then the router already knows what MAC address that you have, what IP that he assigned to you, therefore manipulate some of the bookkeepings. Okay, so that's if you see some of the ARP protocol here, you see this example, ARP. ARP protocols may not be seen very easily. If you're working on Windows, definitely you cannot see it. If you are working on MacBook, at the very first time, when you open it to access Wi-Fi, then you may be able to see that ARP. So you have to, when you open your MacBook, do not connect Wi-Fi until your Wireshark is ready. So your Wireshark is start capturing the packets. After that, you assign, you open that Wi-Fi router. Then you can capture that ARP protocols. Okay. Once the ARP protocol, then after this, your router may understand you. So it's very tricky, right? How come that I can get this ARP before my router knows me? And things like that. How did I capture this? I captured this. I set up a router on my Raspberry Pi. Okay. We need to set up Raspberry Pi router. And then I log in that, I use that my Raspberry Pi router. And then this Wi-Fi is captured within that Wi-Fi, I mean the router, Raspberry Pi. A little bit of a tricky, but this is, that way you can capture this. Okay, now, why ARP is first thing that you need to understand. Okay, so if you see ARP, those two, I want you to look at this. This 2 bytes long, 0806. for the same ARP. Look at this. And next slide. That is not ARP but TCP. If you look at this, 0800. Okay. Previous 0806, 0800. What does that mean? Back here. The next slides, 0806, 000, 0800. If it is 0806, then that is ARP. 0800, then that is IP. Some of that the value on that location tells us what it is. If it is 0806, then ARP, Address Resolution Protocol. Other than that, so many cases, then 0800. So in our case, if you see this, here 0800, right? 0800 means TCP. ARP, very hard to get. As I said, you can get it. Yeah. Why that is important? 0806, 0800. If it is 0806, then there's a first thing that your router make sure your router needs to understand you, which means I need to serve you because I know your MAC address. So when there is a specific IP, which I assigned that IP to your device, when that IP comes in, when some packet comes in, if I know that IP belonging to you, then because I know your MAC address, I can ship my packets into your device. Okay. Once it is done, then after that, that is not router needs to do. Router simply send that package to your device, your laptop. That is only the router needs to do. Everything after that, which is, yeah, everything after that, yeah. Okay. Everything after this, data link layer, once that MAC address is identified, then from here up there, this is your laptop. Laptop needs to. From somewhere here, this is your router needs to do. Your router. Okay. Why it's not sticked together? There's somewhere back. Gray area. Okay. Okay, let's look at the ARP first. Once Ethernet type 0806 is identified, then we see that is an ARP. There in the data type, then we need to verify hardware types, protocol type, which is ARP, hardware address length. This is a hardware address length. This is a protocol address length. And then sender hardware address. This is the MAC address. Address of the sender. And another MAC address here. That is the destination MAC address. Because the MAC address is a unique to each device. So when we unpack, let me go, okay, back. again. When we unpack at the data link layer, as we unpack, then ARP portion will be extracted. So if we see that ARP data, then that router understands which MAC address that I need to which MAC address that I need to send to this current packets. Okay, then it goes into your device. So we can testify some of this. There is a command called ARP minus either Windows or Mac OS. So we can practice that. Then what I want to show to you, there's a table. If this is a IP, then it goes into that MAC address. This is a MAC address. This is IP. So ARP minus A, then you can see it does not show much, but what is my IP? My IP address is 10.71.181.239. It does not show here, right? But because of this router, right? Router needs to show to me. This is our currently I'm connecting to this the university enterprise router. So securely it protect everything, right? But ideally, if I am that router, then I know, for example, hundreds of MAC address and hundreds IP numbers that I can assign. So currently, I know which device is connected to my router. I mean, specifically, which device, but it doesn't show. So I do not want to go back to. then, then if we change this to our lab router, then that is another big issue. But anyway, you can try this at home. If you try this at home, I did this at home, right? So I can see more. For example, I opened, I think 3 of these at home laptops. They're all dynamic, right? This is a Verizon router. Oh, now I know. Verizon router opens something that I can hack, something that I can intrude in to do some of the shell commands, but that is static that you can see. So route 22, the port, no, this is not port number, right? This is simply, yeah, I'm confused. This is not port number, but after this, you may have port numbers. But anyway, this is ARP. So you can also see some of the ARP issues from the TCP dump, sudo TCP dump ARP. Then you can see sudo TCP dump ARP. Then Now listening PK tab, data link layers. So we may be able to see some of the ARP request. Ten dot two 128, 128, 128. This is not mine, right? This is something else. So who has, yeah, this guy didn't block this information for me to look, right? So luckily we can issue this command, sudo TCP dump ARP, then only ARP protocols that we can see. It's handy, right? So currently, for example, this IP, this is MAC address. From here, you may be able to hack some of the devices currently here at the university, Mercer University, Manhattan campus. So knowing this, you may be able to hack, but our router, enterprise router, does not allow for loopback, right? Loopback is not allowed. So you cannot attack your friends within this subnet. Okay, so I'm going to interrupt this to stop. Right now, there's no way that we can stop this. Only one way that we could do is interrupt. Oh, Control C, yeah, interrupt. Then that is dropped. Okay, so ALP. After ALP is unpacked, then we can see the IP data. IP, then only this IP address, right? So we can see the IP address in this the packet structures. So that we have a source IP address and destination IP address. To get to this, then we can see many of these. So version, what is the version of that IP protocol? Header length, this is the length of this. Header only, here up to here, not to this data. This is payload. Type of service, total length, identification, some of the flags that we can see, what type of flags currently set or unset. So we can see it. If you see IP, this is an IP protocol. So there is a flag. 41, that is 1 byte long. Oops. Look at that highlight once. This, right? 40. 40 in hex. 40 in hex can be, let's say, to make it quick. 40 in hex to binary. So what is the 40 in binary? 40 in binary this. Oh, that's too long. So 1 byte too long. Okay, hexa number 40 convert to binary. Binary, therefore, 0, 0, 1, 0, 0, and 0, 0, 0, 0, which is 0, 1. You can see some of this, right? 0, 1, 0, 0, 0, 0, 0, 0. Oh, you can see all of this, right? If you see both that and this, first three 0, 1, 0, and then next 0, 0, 0, 0, 0, 0, 0. That is what this 4, 0 in hex, which is this 4, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 0, up to this, not after this. After that, then there is a 4, 0, 0, 0, right? What does that means here? So 4, 0, there is a 0, 1, 0, right? And then 0, 0, 0, 0. There's a 1 byte from here there, which is, this is a bit number 15 to this is 17, this is 1 byte, 15, 20, 23rd, pin number 23rd, 15, 23rd, and 31. So this is 1 byte. And another, there is all 0. So from here, there is a 2 byte long, right? In this 2 byte long, first 3 bits for flags, and the next 5 bits here plus 8 bits. So 13 bits, that is for fragment offsets. Yeah, here's 13 bits, fragment offsets. These 3 bits explains something. So 3-bit 0, 1, 0. So if first bit is something, then what it means, and uh, for example, flag bits in IP packets, then maybe here. This flag. Okay. So 3 bits flags. Um, okay, first bit is reserved. So it should be set to 0. So ours is set to 0. That's fine, right? The next one is a don't fragment 1 bit. So if it tells me what is 1, what is zeros, and then next one is more fragments. So it tells you something about that. Okay. Didn't explain much. But anyway, so all of this means something. So when you knowingly, unknowingly, you send out data and receiving data, but each every chunk of data, then it can be packed into a packets. That packet is shipped out or shipped and coming in to your device. So part of those can be unpacked by router, and it may be shipped into your laptop, And when it comes into your laptop, then it may further unpack and to identify finally it goes to whom, right, within your laptop. Okay. So what is IP? IP is a special type of packets. So it consists of header and payload. So okay. But it is called datagram based. Uh, what is the datagram? So I can explain that here. Because IP best effort to delivery, this datagram, when you say datagram, then it doesn't really care IP address itself, not the payload. IP address itself does not really make sure if it is it's not connection based. It is called the connectionless. What that means is that between sender and receiver, connection does not need to be established. Okay, therefore it shipped out and then don't care the connections. Shipped out, it goes, it arrives, it reaches at the destination, fine. If it doesn't reach destination, that's fine too. There's no correction mechanism. There's no nothing. It's not like a TCP IP. If it is a TCP IP, for example, when you send the email, then if there is some email dropped in over the course of that network connections, then your sender make sure if your emails reaches at the destination. If it's not reaches, then it's checks something. Corrections is needed. So this IP itself, no connection is established, no session states, no guaranteed reliability, no guaranteed sequence. So as I said here, it is the best effort to delivery. It doesn't mean that it's the best delivery. It doesn't mean that it's accurate delivery. It doesn't mean that it gives you full service. It means I will do my best. If it reaches at the destination, fine. If it doesn't reach, fine too. That is the best effort delivery. Therefore, we call that datagram based, which means it's not connection based. If between two opponents are establishes connections in between, then they can make sure all the time, right? Hey, I sent this. Did you receive? Then the recipient send it back. Yes, I received. Some acknowledgement can be returned back and forth. That is possible at the TCP layer. TCP, which is next protocol. At this IP protocols, datagram based. Unreliable. Okay. After this IP, then we need to look at the port number, which is a UDP or TCP, either UDP or TCP. So after this IP, then after this, there's a TCP. After this IP, maybe UDP also. But right now, we don't see any UDP. If we go further, then we may be able to get more without saving. desktop and see if there is any. There's no UDP. That's likely, right? So what is UDP? UDP also datagram based. What that means, there is a connectionless, unreliable. So usually, if you want to listen to a music from over the internet, then each bit of your music, digital music, not necessarily that we need to check, right? If any portion of the music dropped, you still okay. You can listen. Your ear is not that accurate. I'm not talking about you guys. Maybe you accurate, but usually when you listen, if there is some, it's not like an email. Email, if there is a, for example, Mercy University, then if there is a E dropped, then MRCY, then we do not know that is really Mercy, right? But in music, when you listen, some part, like 1/8 per second.
It's kind of like pixelation, except for an
Yeah.
variation, right? I guess another way to explain it.
Thank you.
You're gonna miss.
Thank you, Raymond. Yeah. Yeah. More. Yeah. You can speak up more. That type of things. So connection not necessarily needed. That's UDP. So musics, videos, that's based on UDP. Video packets, our humanized, for example, visual videos. We see there's a moving objects. It's not really moving, right? For example, when you watch the movie, if someone is running, but if you see that movie film itself, then if you see any frame of that film, typically like 50 years ago, film frame, there's a still image, right? That still images runs so fast. How fast? At least 16 frames per second. Our human eyes can see identify if there is a 15 frames only per second, then we see, oh, this is somehow rough. Human eyes doesn't need to incapable of identifies frames if more than 16 frames runs per second, then human eyes cannot identify each single frames, cannot single out any frames. What is our digital videos? Digital videos, how many frames per second constituted? 30. Even half of that dropped, our eyes cannot identify. Typical theater movies, if it is not digital, like film, plastic films, they use 24 frames. 24, that's enough. 16 minimum. So therefore 24 real films. I'm not sure. Have you seen that real films? When I was young, because we set up some movie clubs. If that is a 2-hour movies, do you know how big a roll of films that we need to carry? There's two big, this big films, if that is 32-inch wide, but 64-inch, this real big ones too. So one maybe 50, it runs 50 minutes. Therefore, long time ago,
Okay.
if you go to the movies, there are at least two players at the back end of the theater. So the projector runs. So the one projector, we have to load the films and rerun it. Always there is somebody to look at that. When it comes to some frames, then the other needs to play. So in the first short second, they overlaid, and then the other one needs to be turned off. If we do not play that accurately, then all of a sudden there's something overlaid. That is all. How come you understand that, Raymond?
Well.
Are you that old?
Kind of, no. So partially, yes. I mean, I'm a little older, but like, my, I guess, thing that I was interested in long ago when I was first in my undergrad was film and like everything about film history, film media, this, that, whatever. So everything, like film,
Yeah.
the styling, the technology behind it, the sound scores, the audio, the syncing, and all. Yeah, yeah.
So that, for example, that film rolls, if it plays so long, then maybe cut somehow, right? Then we can connect it by taping.
Yeah.
If we have a transparent tape, then it's not right. But anyway, that is a datagram, okay? Datagram. I mean, there's a UDP. So UDP data structure is very simple. Anyway, this TCP and UDP, that describes about port numbers. So source port and a destination port. Others checksum, and then still we have the payload. If it is a TCP, then connection oriented. It is reliable, stream based. Almost all the data that we currently have is TCP. Remember that most of this is TCP. We don't see yet any UDP. So if it is a TCP data consists of source port and destination port and sequence number and many others. In somewhere, there is a control bit. So in that control bit, that is 1 byte long, right? That 1 byte long, so we have 8 bits. So urgent bit, acknowledge bit, push bit, reset bit, synchronous bit, and the finish bit. Each one of these tells us something. So part of those, if we want to see here, then so acknowledgement 1 and 2, sequence number, acknowledgement number. So we have here sequence number, acknowledgement number, and then 1 byte from acknowledgement, second byte. So that is from acknowledgement to second byte. This is first byte, and this is second byte. 8010. That tells us about. So if you look at, oh, this is something great. We are grateful. We can still unfold this. Look at that. So this is reserved. First 3 bits reserved, and then fourth bit not set, and then fifth bit, congestion, and after that, echo, after that, urgent, acknowledgement, push, reset, sync, and finish. That can be said here. This is 0, 1, right? This is 0 and 1 here. Okay. Up to this point, I know you guys, oh, I didn't know that packets that much, all kinds of header informations attached to the payload. We simply see when I send the email, then my email only flies. No, it cannot, right? There's just something, all different additional metadata needs to be attached. Therefore, it goes into IP, then connections datagram. TCP, you can understand this, right? It's a connection-oriented, reliable stream, UDP connection list diagram with the ports. And then some other control protocols, ICMP. You see there is some ICMP that you can see. When first, this is something about control. When you see, for example, ping pong connections, then it goes into ICMP. ICMP headers are extracted after IP header is extracted. It sends errors. ICMP structures 1 byte type, 1 byte code, 2 bytes long checksum. Hands-on practice. So this hands-on practice and the real hands-on will be discussed next week. But because of we cannot do this here in person, you may be able to see that hands-on. Sometimes I'm using my cameras and external cameras to show to you. And also it depends on operating systems. Someone has MacBook, someone has Windows, a little bit different, so that I recorded everything. And then you may take a look at as applicable to you. So what is socket? Socket is like this, right? In physical world, this is a socket. Socket is abstraction of the communications. Socket unify communications, so programs do not need to manage low-level network hardware. So when you say socket, it is nothing but IP address, port number, and protocol. All together, we call that socket. There is a socket programmers available. Then they need to deal with this IP address, port number, and protocol all the time. Socket programmers are rare. What that means is that high paid. Plus, you can do the security even higher.
Are they predominantly in networking, or are they throughout?
Everything, right? Yeah. Network included.
Sure.
Right. Types of sockets. There are two types of sockets. Because we are looking at the port number, so that is TCP or UDP. So we'll look at both of these. We'll set up in hands-on. For example, if we are communicating over TCP protocols, then you need to set up TCP server and TCP client. If you are looking at and some of the implementation of UDP, then you need to set up UDP server and UDP clients. You can do that in one same laptop, or you can do that two different laptops. So one laptop as a server, the other laptop as a client, so they can talk. If there is a Windows operating system is involved, then a little bit of issue, but because of the Windows operating systems. But both server and clients are based on the Linux, which is a laptop, or Raspberry Pi. Then nicely you can practice by implementation. For TCP communications, we call that sockets, stream sockets. This is a real name, streams. If there's a UDP, then datagram sockets. As we looked at, if that is stream-based, then that is really connection-oriented. Therefore, that is reliable. That's ordered, error-corrected. If there is a datagram, then that is no connection is needed. Therefore, unreliable. Still best effort. So when I say, for example, in your final exam, then which one is the best effort communication? Number one, TCP. Number two, UDP. Then that means, oh, best, because of the best, hey, UDP. Oh, that is wrong, right? I'm not sure why they call this best effort, but that is by all the time with best effort, then UDP. Is the best effort that comes with the connection list? Yes, they go together. Someone may, is the best effort to requires a connection? No. So UDP, I mean TCP, that usually SSH login, web, email, right? We didn't do this here, right? Flask. Some other course that we did. UDP, then DNS queries, video streams, audio streams, online games. This is phone, voice over IP. So usually when you say socket, then this is a transport layer. Okay. Above this, what is it? Session layer, presentation layer, and application layer. That is this. This is your application, right? Transport layer below, we have a network layer. One below, data link layer. One below, physical layer. So we don't really care about this, right? This is not based upon our application. It's not coding based. Only something that we could do for this is packing and unpacking. Above here, so we need to set up our implementation, our hands-on, so socket programmings. So we need to first create a socket objects. This is an object in object-oriented programming, right? You need to first construct an object of socket. Because a socket is an object of the socket class, and since the socket class has lots of methods available, so one of the methods is send to, another method bind, another method receive from, another method listen. Yeah, those are the methods that we need to see. So here, Python 3, help, socket, then there is a sockets. These are the methods available, right? You may use some of these methods. So class, oops, so socket. So method that we may be able to see. These are the magic methods or dunder, double underscore methods. They're all dunder, right? Underscore, underscore, hash, underscore, 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 index, underscore, 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 int, underscore. These are all magic methods, or we call that special methods. Lots of dunder methods defined, and these are the methods that we may be able to invoke, right? This is one of the big the class definitions. Send, send to. Okay. Receive, RCV, receive from. Why I am saying this? Depending upon your implementation and depending upon the protocol, sometimes you use send, some other times you need to use send to. Okay. So this is the conceptual view. I wanted to, I like this slide. This slide is solely formed by me. I don't see anywhere this. This is created by me. As I program this, but this is very important. So if you're working on UDP, this is the way that you need to the implementer for server and client. Okay. So I want you to keep this in mind. This is very, very important. Socket needs to be first constructed, socket objects. So we call that mysock. The way that we can construct is different depending upon UDP or TCP. If it is UDP, then this is socket constructor. Here's sock diagram. If it is a TCP, sock stream. And then you need to bind it. For example, are you going to accept request from anywhere? Then you need to do open and close immediately. If we have any in between, for example, white space, then white space means something, right? So open and close immediately. There's nothing in between. Then we want to open any. So any clients. It doesn't matter UDP or TCP. You simply open and close. If you want to allow any specific IP as your clients or as your server, if you are using UDP client, then you need to use this. You need to TCP server, then you need to specify here the opponents. IP here, that is opponents. Opponent IP. Port here, that is my port. A little a little bit confused, right? Don't be confused. I'm telling you that when you bind UDP object as a client UDP socket objects, then this IP you may open, or you may strict to any specific server. Then you need to put your server IP if it is a client. If it is a server, I mean, if you are working on server, then usually we open it, right? Client, we specify a specific server. The port number here, this is not my opponent port, but my port. What that means is that when we bind, here's the thing. I want to open my port for this address, this IP. Okay. I want to open this port for this address. That is what I mean by here, binding. My circuit needs to be bind to a specific port. Okay. That is what this binding means. And then connect. UDP, as I said, there is a connection list. TCP, we need to connect. As we connect, we need to first listen. Listen method needs to be activated. So TCP port needs to listen. If it is at the server case, listen. And if there is some opponents coming into that port that I bind already, right? Then I need to construct. Here, by accept. Listen first, and then accept it. As soon as I accept, then I know I have a connection. If it is the case TCP, I know who is my remote IP, who is my remote port number. After that, if it is a UDP, then we use receive from method. If it is a TCP, then receive methods. If it is a UDP, and also if we send, then we need to use send to methods. If we were working on TCP protocol to send the message, then use send. That's what I'm saying here. Send to, then this is a method. They are very similar, send and send to, right? But difference, they didn't say here, right? So be careful. If it's a send, then it'll be used for the TCP protocol. Send to, that is used for UDP protocols. If it is a send to, then here object is socket object. This is a socket object. If it is a TCP, then whose objects? Connection objects. Not the socket objects. Because TCP is a connection-based. So connection is important. UDP, we do not have a connection. Okay? Therefore, I said that table is very, very important. And that table is formed by me from my long-term experience. You guys may be first very confused if you do this circuit programming. Maybe very, very confused because of that difference, right? Knowing this, if you see the code, then you now understand. Aha, right? Here is aha segment. Okay. Therefore, we see the program, real program. connection list server. What is this? If it is a connection list, then UDP, datagram, right? If it is a server, no connection is needed. And therefore, object is whose object? Socket objects. Socket objects can send to. Connection is a client. Client does not need to, right? Connect. There's also socket. All the way socket. So where is the socket? C. Yeah, C here, send it. You can test this. So server program can be tested by client programs. So this is what I want to do. This is in homework assignment. This is a hands-on practice, hands-on lab as a last class of this semester. You can see that next week. As an extra, you may not know this, right? Because you're not a Linux expert at all. But those who are familiar with the Linux, then you can see NC and see the server program and netstat and grab this specific port. Then anything that data comes through that port can be captured by this netstat. Okay, this is your server, right? So you may handle all of this. If it is connection oriented, then this is the server program sequence. This is client program sequence. You need to create the sockets, objects, and bind and listen, and then accept it. Therefore, connection is established. So within that connection, it goes, it runs. Okay, it talk with this clients. So real program, if it is connection server, then we use sock stream. Using sock stream, then we can create a socket. What socket can do is up to the connection. Once it is accept, therefore connection is established, then after that, connection object is used for receive, used for send, right? Send and receive. So basic idea here is you set up server and client, and they can share text messages. Okay, client to say hello server, then server, it text showed up in that the client, the server side. Then at server you can reply, hey, I am server. What's happening, client? Then that shipped to the client. The client to reply back to the server. So back and forth, the text messages. Okay, that is the last homework assignments. So all details will be next week. So basically there is some combinations. So we have UDP. So actually we have a UDP and TCP, right? Two things. Let me protocol wise, UDP and TCP. each a different implementation. And then there is either server or client. So you can say, hey, I want to implement the UDP server program, UDP client program, TCP server program, TCP client program. And then one more option. Here. Deployment. Are you going to deploy this program the same program, same device, or two different device? So same device. In other words, are you going to do that within local or over the network? Two different. In this case, maybe Windows and MacBook, or MacBook and Raspberry Pi, whichever convenient. In my video recording next week, these two, for example, MacBook runs server and Windows runs client. The other way, a little bit of the hassles. And then Raspberry Pi as a server and MacBook as a client. Those are simple because both are Linux based. So you can see all of so many different ways of implementation in recording. Okay, next week. Any question? Okay, there's no question. Then today is the last in-person class, in-class lesson. And then we have one more meeting for learning next week. That is asynchronous. And another online meeting over the Zoom, which is the second week of December during your study week. I am going to give you some of the review of the final exams and then some of the wrap up. Okay, that is what's the remaining. You have some question?
Yeah, related to the server, we have the homework related to the server.
Both. Your homework is this, small video clips. So server and clients talking.
For that purpose, we need to install the server and.
Yeah, the homework assignments is that you can run on the same device within your laptop. You open two terminals. By opening the terminal like this, you can run, for example, I think I have some programs.
So this homework is not this week, right? It's for the last.
Oh no, of course, yeah. You need to. Homework is not ready. Homework will be posted next week, a week later, and then due is another week. Yeah. There's no homework this week. As a simple example, okay, Python, TCP, class server. I run this program. So this guy is waiting. And I open up another Windows. This server program already run here. This is for TCP, right? So this guy is waiting. It's listening. 0 means it is any. And then I can do Python TCP client. Yeah, this is because of the router. Our router. Yeah, you can do that. I need to change it. Let's change it a little bit. Yeah, first, no, not this, but oh yeah, there's a client side. So what is IP? IP is this. So I want to copy this. Server does not need. So server we simply run it. So 20560. So I need to see the client. So in this client, this is not anymore right? This is not the IP that I can see. It should be 10.71.181.230. That, and then should be same, that port goes to that. I think others may be okay if router allows me to. So client. Error 9, bad file descriptor. Yeah, client disconnected. OS error. That is usually the router. Router doesn't.
Oh.
Yeah, router. For example, firewall doesn't allow you to forward that IP, something like that. So it's the firewall errors. These are OS errors. But if you do that at home, it should be okay. And if we do this within this different router, it should be okay. But this lecture will be stopped again. Reset up, it takes time also. So I'm going to stop this. So all details will be remained to you so that you can practice it. I'm sure, not I'm sure. Hopefully you do not have any technical barriers, but do not expect everything goes smoothly. You may have some small here and there, some of the battles that you need to fight against. By doing so, you may build up some of the network, the skill sets. Okay, that is the whole purpose of this homework assignments. It's not like the Python simple code. Once you logically if there is no error, you may get the result. That is a simple Python codings. But this network with Python, yeah, codings given, already given. So you don't need to do code. You simply copy it accurately, runs it, but there's something that you cannot see between your server and client. If it goes even worse, if you need to handle two different laptops, two different devices to communicate, then more issues comes up. Okay, so first, the bigger homework assignments is simple ones. So within the same device, you can practice together. Small portions, two difference. Though small weight, but higher technology required. I would like to give more portions for that, but then it is not really right. I don't expect it. Everyone has the same situations. So each one has all different situations, which I cannot handle. You cannot handle either if you do not have enough tech backgrounds. Right. All right. That's it.
Professor, here, the course you are offering more related to application, it's not available on class registration.
Can you say it again?
Your course related to the applications you are offering in the next semester.
Swift.
Huh?
Swift.
No,
Are you talking about which?
your course for the next semester.
Oh, for the next semester. That is in CISC, Computer Science Master's Program. You can take it from there.
Yeah, like
It is. Oh,
I tried to find it, but it's not available on registration class.
it is. Seminar already registered it. Right.
It's in person or online.
That is in person. Yeah, Wednesday morning.
At Manhattan.
Manhattan.
Then that's it.